Hello students. You're welcome to today's chemistry lesson. We'll be studying chemical combination part 3. In our previous class, we learned about the electronic configuration of atoms. Weak bonds are forces of attraction between molecules and include hydrogen bonds and van der Waals forces. Hydrogen bonding explains important properties of water, while van der Waals forces help explain the behavior of gases. We also studied the two systems of naming compounds. The conventional naming system uses common names such as water and common salt, while the IUPAC naming system uses international scientific rules, for example, dihydrogen oxide for water, and sodium chloride for common salt. Our lesson objective for today is to learn about the states of matter, and to explain the kinetic theory and its applications. We are going to learn about states of matter. Matter exists in three common states: solid, liquid, and gas. Each state of matter behaves differently because of how its particles are arranged. A solid has a fixed shape and a fixed volume. This means its shape and size do not change easily. In solids, the particles are tightly packed together. Examples of solids include stone and ice. When you hold a stone in your hand, its shape does not change. Ice also keeps its shape until it melts. Liquid. A liquid has a fixed volume but no fixed shape. This means it can change its shape to fit the container it is poured into. The particles in liquids are close together but can move around. Examples of liquids are water and oil. When you pour water into a cup or bottle, it takes the shape of that container, but the amount of water remains the same. Gas. A gas has no fixed shape and no fixed volume. This means it spreads out to fill any space available. The particles in gases are far apart and move freely. Examples of gases include air and oxygen. When you blow air into a balloon, it expands to take the shape of the balloon. The kinetic theory of matter states that all matter is made up of tiny particles called atoms or molecules, and these particles are always in constant motion. The word kinetic means movement. This theory helps us understand how matter behaves and how changes of state occur. One application of the kinetic theory is melting. Melting is the change of a solid into a liquid. A common example is ice changing into water. When a solid is heated, its particles gain kinetic energy and begin to vibrate faster. As the vibration increases, the particles overcome the forces holding them together and start to move freely, causing the solid to melt into a liquid. Another application is freezing. Freezing is the change of a liquid into a solid. An example of freezing is water turning into ice. When a liquid is cooled, its particles lose kinetic energy and their movement slows down. The forces of attraction then pull the particles closer together and fix them in position, forming a solid. The kinetic theory also explains boiling. Boiling is the change of a liquid into a gas throughout the liquid. For example, when water boils, it changes into steam. When a liquid is heated, its particles gain enough energy to completely break free from one another. The particles move far apart and escape as gas. You're making progress, keep it up. Another process explained by the kinetic theory is evaporation. Evaporation is the slow change of a liquid into a gas at any temperature. A common example is wet clothes drying in the sun. Some particles at the surface of the liquid have higher energy and are able to escape into the air as gas. This causes cooling because the high-energy particles leave the liquid. The kinetic theory also explains diffusion of gases. Diffusion is the movement of gas particles from a region of high concentration to a region of low concentration. For example, the smell of perfume spreads across a room. Gas particles move freely and randomly, which allows gases to mix evenly. Finally, the kinetic theory explains osmosis. Osmosis is the movement of water molecules through a semi-permeable membrane from a region of high water concentration to a region of low water concentration. An example of osmosis is dropping of colored dyes in water. Water molecules are always moving, and their kinetic energy allows them to pass through the membrane. Congratulations on completing this lesson. You should be proud of yourself. Let's answer a few short questions to help us remember what we've learned so far. In today's lesson, we learned about the states of matter, which are solid, liquid, and gas. Each state of matter behaves differently under various conditions, because of the way its particles are arranged. We also studied the kinetic theory of matter, which explains that particles of matter are in constant motion. The applications of this theory can be seen in processes such as melting, boiling, freezing, evaporation, diffusion, and osmosis. I hope you enjoyed the lesson and gained useful insights. In our next class, we will study gas laws, Part 1. Thank you.